Yo, for real, could something in our universe actually move faster than light? I mean, Einstein himself called the whole idea spooky BS. It's this wild phenomenon called quantum entanglement, where particles can literally zap information to each other across the universe instantly. This idea was so out there, it took another physicist, John Bell, to finally prove that our nice, neat view of reality was just plain wrong. Turns out, the universe is fundamentally non-local, dude. Let's get into it.
All right, so picture this. It's 1927, and Einstein is at this epic physics conference. He's looking at the math behind the new quantum theory, and he sees something that makes him hit the brakes, hard. He called it spooky action at a distance, and for him, it was a massive red flag, a total contradiction to everything he'd established. He just wasn't buying it.
And that, spooky action, is what this is all about. We are going to crack open the mystery of the universe's ultimate speed limit. And trust me, it's a story that starts with Einstein, but ends up rewriting the rulebook on reality itself.
So, to get why this was such a big deal, we first got to understand the law of the land. Einstein's whole theory of relativity, it's built on one core principle that runs the entire universe.
It's called locality, and it's pretty simple, right? It just means something can only be affected by what's right next to it. Like, if the sun just, poof, vanished, we wouldn't know about it for a full 8 minutes. That's how long it takes light and gravity to make the trip. This cosmic speed limit is absolutely crucial. Without it, cause and effect go right out the window, and the universe becomes total chaos.
So, with that law firmly in mind, Einstein starts digging into quantum mechanics, and what he finds looks to him like a full-blown cosmic crime scene. He found a clue that suggested this new theory was breaking his #1 rule.
The culprit is this mind-bending thing called quantum entanglement. So, imagine two particles get linked up. They become these quantum twins that are tied together, sharing the same fate. Now, here's the crazy part. No matter how far apart they get, we're talking light years apart, what happens to one of them instantly affects the other. And I mean like 0 time delay instantly.
So Einstein cooks up this thought experiment. You create two entangled particles with opposite spins. Say one's up, the other's down. Then you shoot them off to opposite ends of the galaxy. Now, you measure particle A. The second you see its spin is up, you know at that exact same instant that particle B's spin has to be down. That information, that knowledge, seemed to travel faster than light. And for Einstein, that was a huge no way.
So Einstein came up with a fix. He said there must be some local hidden variables. Think of them like secret instructions the particles are carrying from the very beginning. It's kind of like putting a pair of gloves into two separate boxes. If you open one box and find the left glove, you instantly know the other box has the right one. No spooky, faster-than-light communication needed. The info is there all along.
But here's where the story gets wild. For almost 30 years, nobody really took him seriously. The physics world basically followed this other guy, Niels Bohr, and they all just brushed off Einstein's worries as, philosophy. So the case went totally cold. Until 1964, when a physicist named John Bell dug up Einstein's old paper. Bell realized this wasn't just philosophy at all. This was something you could actually test in a lab. He came up with this brilliant experiment that could finally settle it once and for all. Is reality local, like Einstein thought? Or is it spooky and non-local, like quantum mechanics was saying? So Bell sets up the ultimate showdown. He designs this experiment where they measure entangled particles at a bunch of different random angles. And his math led to two totally different predictions. If quantum mechanics was right and this spooky connection was real, the results should disagree 25% of the time. But if Einstein was right with his hidden variables, the disagreement rate had to be more than 33%. The whole debate about the nature of reality boiled down to a single number.
Okay, fast forward to the 1980s. A team led by this guy, Elaine Aspect, finally runs the experiment. They create the entangled particles, they send them flying, they measure them, all ready to get the final verdict on reality itself. And the results were insane. The disagreement rate, again and again, clocked in at 25%, exactly what quantum mechanics predicted. The universe is officially spooky, dude. Einstein's common sense local reality just got blown up by the evidence.
And the takeaway here is huge. I mean, just listen to John Bell himself.
The experiments force us to accept it. There are, in fact, actions in our universe that travel faster than light. Reality is non-local. Period.
So, does that mean the great Albert Einstein was just wrong? Well, kind of yes, kind of no. He was wrong about his solution, the whole hidden variables thing. But he was totally right to be worried.
His skepticism, his refusal to just shut up and do the math, is what forced everyone to actually look at this problem. And it led us straight to discovering non-locality and entanglement, which are like two of the absolute cornerstones of modern physics.
But hold on a second. If there's faster-than-light action, doesn't that completely wreck everything we know about time travel and causality? Well, there might be an escape hatch from the paradox, but it's going to get weird.
First off, it's super important to get this. You can't use entanglement to build an FTL telephone. Why not? Because even though the particles are linked, the outcome of any measurement is totally random. You might measure spin up, and your friend instantly gets spin down, but you had zero control over that. You can't send a message with random chance. So, for now at least, causality is safe.
Now for the truly wild part. There's another way to look at all this, called the many worlds theory. It says that when you measure a particle, it doesn't just collapse into one state. Nope, instead, the entire universe splits. In one universe, you measure up, and in a brand new, parallel universe that just popped into existence, another you measures down. Both things happen.
And this basically sums up the choice we're left with. We can go with the standard view, one universe, but with spooky, faster-than-light connections tying everything together. Or we can choose the many worlds idea. A nice, local universe where nothing breaks the speed of light, but the price is creating an infinite number of parallel worlds every single second. So, you want a spooky universe or a really, really crowded one?
So, what do you think? Which reality is actually weirder? A single universe where particles are connected by some mysterious, instant link that defies all our old rules, or a reality that splits into endless copies of itself with every single quantum event? Physics hasn't given us the final answer yet, which leaves us to just wonder.
And that's our deep dive into one of the biggest head-scratchers in all of physics. If you want to keep exploring the craziest parts of reality, smash subscribe for more quantum shocks. Don't miss the universe's wildest secrets. We'll catch you in the next one.